All right, hello everyone. This is Mr. Crozier. I'm going to go over our review 1B packet and give you some help on it and show you what the right answers are. So problem number one, if you're looking for the limit to infinity, you just look at the leading term, and the leading term in this case is 500t over 20t, and if you reduce it here, all you have to do is divide 500 divided by 20, and you get 25. So that's the population at infinity. On problem number two, again, if you are looking for when the function is greater than 0, when it's above the axis, you're going to look at the critical points. And the critical points here are a -2 and 1. That's a 0, that's a whole, and so we have these three sections. And if we put a number that's bigger than 1 into here, we have positive over a positive, which is positive above the axis. If we put 0 in here, we have a positive over a negative, which is a negative, which is below the axis. And if we have two numbers here, we have negative divided by negative is positive above the axis. So this graph goes above, below, above the axis. All right, number three. We have a function with 2 zeros and 2 asymptotes. On number 4, we have a problem where we're going to take this function and move it up by 4. So if this graph right here goes up 4, the coordinate would be 12, 0, which is what we're looking for. So function transformed up 4 spaces. We move this one up 4. We're at 0, which we need to be. On the next one, the limit as we go to -1 from the left side, it's going to infinity. -1 from the right side, down. 1 from the left side, down. 1 from the right side, up. These are left, right, left, right. Those are the sides it comes from. In behavior here, we only look at the leading term, which is x squared over 3x, which reduces to x divided by 3. We plug in infinity divided by 3, and a negative infinity. On problem 7, it's the exact opposite. The bottom degree is bigger, so we have a 1 over an x, or we have an x over an x squared. Well, whatever it is, the bottom is bigger, so it's 1 over infinity, which leads us to 0. On the second page, on the x-intercepts, again, we put a 0 here, multiply this over, and then we're just solving this. Now, to solve this is a cubic function, which we're not going to be able to solve, so what I can do is just graph this, and I can graph y is equal to 6x cubed minus 5x plus 2, and graph, I'm in the wrong window there. Take a look at my window. I'm going out to 50. So I just hit zoom 6. There's my graph. So I do have that one intercept right there. Let me zoom in on it. Let me zoom a box around this. I'm going to go over and put a box around just what I want to see, just that one intercept. And if I trace it, or if I just move my cursor over here, let's see, it looks like about -1 something. But if I want to find it exactly, I can use this calc feature, and I hit second, calc, and now I have a 0, or a number 2 is a 0 feature. So I hit 0, and what I'm going to do is I'm going to go left of it. Sometimes it's a little bit hard to find, but there's my cursor. So I'm going to guess on the left side of the 0, then I'm going to guess on the right side of the 0, left, right, and now I'm going to guess where my 0 is, probably about right there. Press enter. My calculator is going to go ahead and do the math and round it for me, -1.07. So you can use that feature, that 0 feature right there. You can find values on your graph. You can find zeros. You can find mins. You can find max. You can find where 2 points intersect. And choices 6 and 7 are stuff that you're going to use in calculus. All right, let's go on. Vertical asymptotes. Well, if you cross off the holes, you're left with 2 asymptotes. On number 10, this one's a little tricky. To find the location of a hole, we want something where the top is 0 and the bottom is 0. So we're looking for a place where both of them are 0, because that's a hole that we can cross off, just like we did up here. And the way I found that there was a hole here was I graphed both of them. And if you graph this equation and this equation, you will see that at -1 they both cross. So there's going to be a hole there. Just like here, there's a 5 and a 5. If you graph both of these, 1/2 works. And you can plug in 1/2 and you can estimate it's close to 4.3. On number 12, factor it and you can find the 3 zeros. All of these, if you input any of these numbers, 3 minus 0 is 0, the whole thing's 0. So these 3 numbers will give you an output of 0. On number 3, it's a limit problem. I'm going to 2, not to infinity now, so I'm going to 2 from the left. So if I go to 2, this graph is going to 3. And if I go to 2 from the right side, well, it looks like it's going to 3 also. And number 14, what type of graph is represented by this data? Well, think about if I were to graph this. The graph's going to be 20 for a while, then the outputs are going to be 24 for a while, then the outputs are going to be 27. That's a piecewise function. It's not linear, it's not quadratic, it's not cubic, it's not quartic. It's all different pieces. All right, that's where we're going to start with our homework today.